Okay, today we're going to talk about a couple of special cases for exponents. So you should have hopefully learned about 3 laws of exponents in yesterday's class. If not, you will finish that up later today. But before we get to that, I want to talk about a couple of special cases for exponents. And what we can see is I have typed out for you at the start that we have 10 squared is equal to 100. If that's not obvious for you, if you don't know that already, the reason for that is because 10 squared is equal to 10 times 10. So we take that base of 10, and we multiply it times itself 2 times. 10 times 10, that is equal to 100. For 10 cubed, that is equal to 1,000. Because this would be 10 times 10 times 10, where we multiply 10 times itself 3 times. The key thing that I want you to notice I'm going over right now is that each time we increase this exponent by 1, we're going to be multiplying it by the base 1 additional time. So for example, when we had 10 squared, with the exponent of 2, we multiplied it with 2 tens here. When we go up to 3, we now have 3 tens. If we make the power 4, we would then have 4 tens. And that would make it 10,000. And so in essence, each time we add 1 to this exponent here, we're going to be multiplying our previous number by 10. So we go 100 times 10, that's 1,000. 1,000 times 10 is 10,000. So if I did 10 to the 5th power, without expanding this, I should be able to tell that this is going to be 10,000 times 10. And you can plug this into your calculator if you would like to, but anytime you multiply by 10, you just have to add a 0 basically to the end. And so this 10,000 would become 100,000. So we can see that as this exponent increases by 1, we're multiplying each of these by 10. Now let's look at the case where we have 2 as our base. We have 2 squared here, that is 2 times 2, so that's equal to 4. If the pattern continues, we should see that we're going to multiply our previous number by our base. So 4 times 2 should get us our next number, and that would be 8. If we expand that 2 cubed, we can see that we would get 2 times 2 times 2, because we have a base of 2, that's 3 times. 2 times 2 is 4, times 2 again, that is 8. So we can see that this is true, that when we increase this exponent by 1, we're again going to multiply our previous number by that base one more time. So we should see again, if we wanted to do 2 to the 4th, we could just take 8 and multiply it by 2, and that would give us 16. But what if we wanted to go in the other direction? Instead of going up with our exponent, what if we wanted to decrease our exponent? So let's say if we started at 2 to the 4th, and we wanted to go down 1 to 2 to the 3, or 2 to the 3rd power. Then, instead of multiplying by 2, in order to go down a step, we would divide by 2. And then to go down from 8 to 4, divide by 2 again. Okay. This works the same way with 10 as the base. It'll work the same way for all numbers. If we're starting at 10 to the 5th, that is 100,000. In order to get down to 10 to the 4th, we need to divide by 10. And we're going to divide by 10 at each step to get to the next number if we're going to decrease the exponent by 1. So what if I wanted to decrease this from 10 squared to 10 to the first power? anytime there's a number with the first power, you actually don't need to write the 1, because any number that doesn't have an exponent is just assumed to be an exponent of 1. But if we wanted to decrease this from 10 squared to 10 to the first power, we could take this number that we got for 10 squared, and we can divide it by our base of 10. 100 divided by 10 is just 10. And this makes sense because we have 10 to the first power. That means we're just going to have one 10. You don't need to multiply it by another 10. So 10 to the first power would equal just 10. And same thing, we could do this with the 2's. If we took this number of 4 that we have with 2 squared, if you wanted to bring it down to 2 to the first power, we can take this number 4, divide it by our base of 2, and that would give us 2. 2 to the first power is equal to 2. What if I wanted to go a step further? Right now I have an exponent of 1. If I decrease that exponent by 1, I would now have 10 to the 0th power, or 10 with an exponent of 0. But again, I'm just going to continue the same pattern. So if I'm going to go down one step, I'm once again going to divide by the base, which in this case is 10. So 10 divided by 10 would just be 1. And I can do the same thing with the 2's as well. If I decrease this from 2 to the first power, and I make it 2 to the 0th power, I can divide that 2 by our base of 2, and 2 divided by 2 would equal 1. So that's our first kind of special case, our first law of exponent that we're learning today, is that if you look down here, we have a to the power of 0. A just represents any number. So if you have any number and you have an exponent of 0, that's always going to be equal to 1. So no matter what, if you have an exponent of 0, that will always be equal to 1. So for example, we can pick any number. I'll just pick 25. If we had 25 to the power of 0, that would be equal to 1. But what if I'm not satisfied at this 0th power? What if I want to go a step further and go to 10 to the negative 1? Again, I'm going to decrease this exponent by 1. So I'm going to go from 0 to negative 1. And once again, I'm going to divide that previous number by the base to get to the new number. Okay, so I'm going to take 1 divided by 10. That's going to give me 1/10. And I can do the same thing once again with the 2's. To go to 2 to the negative 1, I would divide that 1 by the base of 2, and I would get 1/2, or 1 over 2. We can continue this process. So if we wanted to go 10 to the negative 2, we could take 1/10 divided by 10, and for this I might recommend getting out your calculator. Do 1/10 and then divide by 10, and that gives you the decimal 0.01, which that as a fraction is 1 over 100. So if we divided it by 10 here, this 1/10 divided by 10 would be 1/100th. Same thing here. If we take 1/2, so 1 divided by 2, and we divide it by 2 again, that gets us 0.25. So 2 to the power of negative 2 is 0.25, which as a fraction is 1/4. 0.25 as a fraction is 1/4. The key thing to note here is that this 100 is equal to 10 squared. So if we have 10 to the negative 2, we actually have 1 over 10 squared. And same thing with the 2's, that 4 equals 2 squared. And so 2 to the negative 2 would equal 1 over 2 squared. And once again, we could continue this pattern. So we could go 10 to the negative 3, and we would end up getting 1 over 10 cubed. And if we do 2 to the negative 3, we get 1 over 2 cubed. Each time we decrease it, we're going to be adding another of the exponent in the denominator of this fraction. So that's our second law that we're learning today, is that if you have a negative exponent, and again, this a represents any number, so if you have any number with a negative exponent, what that means is that you can simplify that to 1 over that number with the exponent in the denominator. So essentially, that negative number just means you can move it to the denominator and make it a positive. So for example, we could have 3 to the power of negative 4. This would be equal to 1 over 3 to the 4th power. I want you to use these two laws, as well as the laws that you learned yesterday, to work on these 4 practice problems. And once you have attempted these and gotten an answer for them, go ahead and watch the next video to check your work.